analysis. Okay, now it's sharing. Can you see the screen?
Yeah, I can see it now.
Okay. So once again, coming back to these reasoning questions of mathematical nature, number of properties, remainders, data sufficiency question. So once again, it's a brainstorming, and definitely you will find so many tips and tricks to tackle these type of the problems. At the end, after this lesson, I will send you a few questions for your practice for the long weekend. Okay, so
Okay.
let's see. Please read this question now.
What is the remainder when the positive integer x is divided by 6? 1, when x is divided by 7, the remainder is 5. 2, when x is divided by 9, the remainder is 3.
Okay, what is the remainder when the positive integer x is divided by 6? So we don't know
Okay.
about the x, but we are
Yeah.
dividing this positive integer by 6. When x is divided by 7, the remainder is 5. When x
Okay.
is divided by 9, the remainder is 3. So these are the extra information, but I mean to say these are the helping for the solution to get the remainder when that positive number is divided by 6. So it's let's see if you have any idea, if you are just working on any, I mean to
Yeah,
say,
okay.
a tip. So it's little time for you just to think about that.
Okay. Well, do you want me to tell you what I'm thinking or?
Okay. When you will, what I mean to say, if you have any idea, so you can talk about any stage. Okay. Keep on working with that.
Sure.
Okay. And we will continue also. So definitely after the few steps, you will be in a position to continue your thinking or just switching over to the new idea. Okay.
Okay.
So it's
Sure.
just what I mean to say, just ignite your mind just to make it more active. If you are thinking just now, right from this point about the solution, so definitely you will get some idea. And
Okay.
I will show you the points. We will proceed to the next step, and at that time you can switch over to your idea that how what you are thinking
Okay.
at this stage and how the things are going. So that may be
Okay.
matching with your thinking. Okay.
Right.
So
Okay.
so the first is actually we will do these steps. This is the question you see at the bottom of my screen. And now you are to question,
Right.
and then question stem, and then approach. Then
Okay.
statement one is this one, and statement two. Then we will combine these two statements, and finally you will get the answer. Okay. So these are the
Okay.
steps. So first, the question is in front of us. Next is that
Right.
question stem, and the this one is the approach that we will have to think about, that on which way we will have to go. And the statement
Okay.
one is this one, and statement two. So these are the statements. We'll have to combine these two statements, and then we will have to do something, and we will get the answer. So it's a very interesting way that if you have a problem, you are not just getting the answer at the first instance. All of a sudden, you are getting the answer. It's not a way. What I mean to say. So it's a, now there is a suspense that what is the answer? I can give
Yeah.
you the answer of these type of a question just within the seconds. But that is without
Right.
understanding. So answers are everywhere. We can put the answer, we can show the answer, but that is not the way. So right now we are totally blank. We don't know what is
Yeah.
the
Okay.
that required number, that what is the remainder when the positive integer is divided by 6. So only the divisor is given, not the dividend, not the quotient, not the whatsoever, nothing is given. But these two statements are just helping for us. Now, this is a way to actually, uh, what I am saying that I am feeling the inner satisfaction in this way that I must come up with some tips, tricks, and the depth of the knowledge, the concepts must be clear. And if you know all these
Okay.
things, if you know all these things, definitely these are helpful for your next assignment. So whenever you will
Okay.
see whenever you will see the real question, so definitely that time you will recall all these things, how to proceed, how to start. It's a very big step just to start a problem. That's the
Right.
way to the solution. That's why I used to say that whenever there's a problem, take time to think because it is the right way to get the right solution. I'm sure that you got this point. Okay. Now let's see.
Okay.
This is a point, and from here we will have to start our journey to find that required answer. I'm sure you are with me. Okay.
Right.
Let's see. So the step 1, please read this one.
Okay. Step 1, answer these questions before evaluating the statements. Determine approach to solve the question.
Okay, so we will have to ask some questions. So by answering those questions, we will get the right approach to solve the question. And that is our ultimate goal. Okay, now let's
Okay.
see how. Before going to the statements, spend a few seconds answering the following questions. You can also participate in answering.
Right. Okay.
Right way. You are the active player of this game now.
Okay.
So please, the first question is.
When is the data sufficient?
Okay, can you think about this sufficiency? That if a problem is there, and once again, if you can see the problem, so you can say that we are looking for the remainder when any number that digit x is divided by 6. So what is the remainder? Okay. So
Okay.
when the data is sufficient, so what I mean to say, if this problem is given to you, so you say, please, it's another sufficient data. What I will have to
Right.
do? Only you have given the 6, and this with this 6, what I will have to do? Okay. When is the data sufficient? We should ask ourselves
Okay.
that there must be some more information is given. Okay. The answer is this one. Please.
Okay. The data is sufficient when we are able to find a unique remainder.
Okay. So the data is sufficient when we are able to find a unique remainder. So we are looking for that remainder. Then when a number x is divided by 6, we will get a remainder. So it's a problem. So from here,
Okay.
what we should say, the data is sufficient when we are able to find a unique remainder. Now look at this. So we have this, and next question is, when it is not
When is it?
sufficient,
Oh. Okay. When is it
is
not sufficient?
not sufficient. The sufficiency is this one, that that sufficient data must be given that we can find the unique remainder. When it is not sufficient, the answer is
The data is not sufficient when we get more than one remainder using the information in the statements.
okay. So this is all about that. That's why these two statements are given over there. when we cannot find the unique remainder, we can find so many remainders. So that's why we can say that at this stage, the data is not sufficient.
Okay.
Now let's see. What do we know about X?
Do you want me to say, or we know that it's if you divide it by 7, you could get 5, and if you divide it by 9, you get 3.
Okay.
And it's
X
positive.
is a positive integer. One
Yeah.
thing is that X is, those are two the statements, those are two conditions. But what about
okay.
all alone? All alone is
Right.
X. That's also right. Those are the
Yeah,
what we
okay.
can say the supplementary conditions that from there we will have to. So these are the three questions that before adopting any way to reach the answer, we must ask these questions.
Okay.
When is the data sufficient? We know the data is sufficient when we can find the desired and required remainder. Not sufficient, we cannot get the unique, we can get some, you can say just like that if X is 9, divide this, so 3 is the remainder. If X is 12, 0 is the remainder. So there are so many
Yeah.
choices. There are so we are not
Right.
getting only a single answer though. So that's why if you can find the value of X and you have so many answers, so that means this data is not sufficient. Anyhow,
Okay.
what do you know about the X that we should just focus about the positive integer? So forget about the negative one.
Yeah.
So these are the three questions. Now the next is approach. Look for a counter example. So we will have to just get approach to solve the question is look
Right.
for a counter example. What I mean to say that if we are just the argument of any person, so we are giving so many examples for the better understanding. Better understand. Okay. Look for a counterexample mean if a counterexample exists, data not sufficient. There is
Right.
another example, so it's not sufficient to get the answer because examples are not the exact solution. These are just the examples. These are just the samples. Okay, let's
Right.
see. So we are still looking for the right approach. Next is please repeat.
Yeah. Okay. If a counterexample does not exist, data is sufficient.
Yes. So these are the two contradictory statements with each other. This is totally opposite to that. If counterexample exists, data not sufficient. If a counterexample does not exist, does not exist, data sufficient. Okay, in this way, we can just correlate these two examples, look for a counterexample. So we will have to select the example, or what I mean to say that the example is there and that example is not supplementing that. So it's enough. If a counterexample does not exist, if we are not just finding the example, so we say that there must be the only way that must be the solution, approaching to a solution. Let's see anyhow. Look for a counterexample. Next one is what is a counterexample? So let's see in this situation, in daily life, we are used to put so many examples for the easy understanding, for the more explanation. But in this case, when a particular mathematical problem is given, you're talking about the numbers and your required and desired answer is also a number that is a positive integer. So how can we correlate or how can we put the right example? Okay, there are so many examples. Please read this one.
Sure. Find two values for x satisfying information in the statement, each one resulting in a different remainder when divided by 6.
Okay, so this is a counter example. that if you can find two values of x, because if you know the x, you can find the remainder because divisor is also given. And every time you are getting the different remainder when it is divided by 6. So that is called the counter example. So in this way,
Okay.
you can get 1,000 examples and you can get the 1,000 remainder. So from those thousands, how can you select your required and desired remainder? So that's why if these type of the examples are over there, so these are not helping to the answering this question. Okay, are you getting this
Okay.
one? Then what is the counter
Yep.
example? Counter example in the sense that as many examples you are getting, every time you are distracting from the right answer, you are getting different answer. You are not getting the unique answer. So that's why examples are existing, but these are the counter examples. So whatsoever the example you are using, so every time you are getting a different answer. So out of those answers, you cannot select the right answer. So that's why these examples are not helpful. That's why these are called the counter example. If two such values exist, then a counter example exists. So definitely we can put any assign any value to x, we will get the result. The third one is if for all x satisfying information in the statement, the remainder is unique, a counter example does not exist. So it's a very important. Please read this one.
Sure. If for all x satisfying information in the statement, the remainder is unique, a counterexample does not exist.
Okay. If we can find if for all x satisfying information in the statement, the remainder is unique. A counterexample does not exist.
Okay.
It's mean if you are just looking for the value of x and you are putting that value and you're getting a single answer. But somebody says, yeah, put this x for the value of this. So if this counterexample does not exist, then you can say that we will get the only one thing and we will get the unique answer. There are so many examples,
Okay.
so we will be mixed up with those. So that's why this is the existence of counterexample. Step
Okay.
2. Step 2 is evaluate statement 1 alone. The two statements were given in the beginning. So we will have to just analyze these statement 1. That is that what is, I mean to say, if you are just putting over here, look at this, that
Okay.
what is the remainder when the positive integer x is divided by 6? This is our problem. And let evaluate statement 1. This statement was when x is divided by 7, the remainder is 5.
Yeah.
Okay, now it's very interesting. Can we find the x from this statement?
Yeah.
So what should be
You
that?
just multiply 7 on both sides, and you could get x is equal to 35.
Okay, so from here, statement 1 is just giving us the value of x. Look for a counter example. Okay, the x is 5.
Okay.
X is 5. Leave a remainder of 5 when divided by 7. Am I right?
Okay. Yep.
So it's a mathematical operation. If you are
Yeah.
just thinking about that x is 5, divide this,
Okay.
so you will get the 5 is the remainder. Leaves a remainder of 5 when divided by 6. Okay. So look back to the original problem that is at the top of our screen. What is the remainder when the positive integer x is divided by 6? So from this statement, if you are putting x is equal to 5 and dividing by 7, the remainder is 5. And if we are considering this one, that leaves a remainder of 5 when divided by 6. So
Right.
similarly, if we are dividing that integer, supposed integer x, with our divisor 6, once again we are getting 5.
Yeah.
So in this way, this is the digit x. When it is divided by 7, the remainder is 5. When it is divided by 6, once again the remainder is 5. So this is the first example.
Okay.
How do we find the next number that satisfies the statement 1? Okay. Now,
Okay.
statement 1 is that when x is divided by 7, the remainder is 5. The x
Right.
is, this is the x, that's why we are putting x is equal to 5 to get the remainder.
Yeah.
So how do we find the next number that satisfies statement 1? That we are looking for another number where we are putting that dividing by 7, we are getting the same remainder 5.
Right.
Values satisfying first statement will be in an arithmetic progression. First term is 5 and common difference is 7. Then sequence is 5. Next you can select the 12 divides by 7. You will get the 5, 19. You once again you will get the same 26. At the end, after the few steps, you will get 5. Am I right?
Right.
Are you getting this sequence?
Yeah, I get it.
Okay. So 5 is the least number. You cannot take
Okay.
4. You cannot take 4. Why? If you are dividing by 7, you cannot get the remainder 5.
Right.
So that's why 5, our sequence is starting from 5. And it's
Yeah. Okay.
going on. So that is the common difference 7. So every time we are adding 7, we are getting the remainder 5. So this is a way to get so many examples. So let's
Okay.
see. Let's see. Let's find out the remainder when x is 12. So 7, another 7,
Okay.
12.
So yeah.
You will get the 5. Then
Right.
x is 12. Leave a remainder of 5 and divide by 7. Okay. Leaves the remainder
Okay.
of 5 when divided by 7. So
Right.
leaves the remainder of 0 when divided by 6. Okay, look at this. So at this time, if you are taking x is 5, so we are dividing the 6, our given divisor, we are getting 5. But this number, that is both divisible by 7 and also divisible by 6. If we are dividing this with 7, we are getting the remainder 5. But if we are dividing with 6, we are getting the remainder 0. So 12
Right.
divided by 6, answer is 0. Counterexample exists. Statement 1 not alone is sufficient. Okay.
Okay.
From these two examples, from this discussion, we say that counterexample exists. That if you are considering this and you are getting this and 6 dividing by 6, you are getting the answer 5. And somebody is putting x satisfying this condition, this statement, then he is dividing that number with 6, he is getting the 0 remainder. So that's why
Right.
the answer is not unique. What I mean to say, we are not getting the unique answer. If we are not getting the
Yeah.
unique answer, then the counter examples are given. So
Okay.
counter examples are given. So when we are in an argument and we are used to put the example, so somebody is putting the counter example. He can
Right.
say that this is the example of this, this is the example of this. So in this way, we cannot reach on the, what we can say, unanimous decision. So that's why if the counter examples are existing in any case or any problem, so we cannot reach the agreement. So the case is over here that if all alone we are thinking about that this statement is helping statement 1 when x is divided by 7, the remainder is 5 is sufficient to get the right answer. So counter
Right.
example exists. Statement 1 alone is not sufficient. Are you getting this point?
Okay.
Are you with
Yep.
me? Are you with me?
Yep. Yeah.
Is there any ambiguity or any problem or any confusion?
No, I get it.
Okay, yes. So eliminate choice A and D. What I mean to say that this is not the right answer. So look at this. Choice is narrow. Now we are eliminating A. Step 3, evaluate statement 2 alone. Now we are just going to the statement 2. That is, statement 2 states that when x is divided by 9, the remainder is 3. That was the second statement. So
Yeah.
if we are looking x is 3, leaves the remainder 3 when divided by 9. So
Okay.
leaves the remainder 3 when divided by 6 also. So with our given divisor, with the divisor given in the statement, so at both the time we are getting the same remainder,
Okay.
same remainder. And then how do we find the next number that satisfies the statement 2? That we will have to values satisfying second statement will be in an arithmetic progression. First term is 3 and the common difference is 9. The sequence is 3, 12, 21, 30. So look at this.
Okay.
So all these numbers starting from 6, if we are dividing with 9, so every time we are getting 3 as a remainder. Am I right? So
Yep.
this is a sequence. So out of these numbers, once again 12 is there. So if you are dividing
Right.
this 12 as we have divided over here, the same time we are getting the same remainder, but here that will give us a 0 remainder. So let's find out the remainder when x is 12. So that will be when you are putting the counter example that just look at this. If you are dividing 3 with 9, you are getting 6 as a remainder. If you are dividing 3 with 6, you are also getting the 3. But look at this. If you are dividing 12 with 9, you are getting the 3 as a remainder. But when you are dividing with 6, you are getting the 0 remainder. Leaves a remainder of
Right.
0 when divided by 6. So this is a counter example.
Okay.
So that's why counter example exists. Statement 2 alone is not sufficient. That this statement all alone is not sufficient. Then what we'll have to do? Once again, we'll have to call the mathematical, what we can say, magic. How? Eliminate choice B as well. So B choice is not there. That these actually, when we are talking about the choices, actually choices are not given to you. These choices are understood that A is alone one first statement, B is alone B, then third one is either this or that, then this or B second. So in this way, we can make so many choices up to E. So that's why I have not written all those choices because these are repeatedly coming on there.
Okay.
I will show you. But anyhow, the B's choice is also B is A is that all alone the first statement. B is all alone the second. C is
Right.
either any one of these two. The D is neither these two. And the last one is combination of these two. So these are all the 5 statements. So these are understood. So that's why I have not written over there. So eliminate choices B as well. So B is eliminated. That all alone if you are taking this statement, so this is sufficient to get the answer. So what we'll have to do, then combine. We'll combine these two. So choice is now coming narrow. That the first two is eliminated. So this is
Okay.
called the negation rule. So we'll have to negate these two choices. Now we left only 3 choices, C, D, and E. Let's see. Step 4 is evaluate the data given the two statements together. Now we'll put the two statements all together and then we'll have to find out that unique answer. Because if we
Right.
are using the first statement all alone, we are not getting the unique answer. If we are taking the second statement, then we are once again we are not getting the unique remainder for that problem. Okay, let's see. Now look for a counter example. Now these statements are given to you. that x is divided by
Okay.
7, the remainder is 5. And the second one is x is divided by 9, the remainder is 3. So it's written in the combination instead of first and second. This is state with a combination of two statements. Let
Right.
x is 12. Let x is 12. Leaves the remainder of 5 when divided by 7. So if you are taking
Okay.
12, the remainder is what we can say 5. 12 divided by 7, 5. And leaves a remainder of 3 when divided by 9. So 12 is the unique number. When we are dividing this 12 is satisfying both the condition. So leaves a remainder 0 when divided by 6. Now we have selected, we have actually supposed that x is 12. So we are utilizing these two given conditions and the real problem. What I mean to say, this time we are given the 7 first divisor, the second one is 9, the second divisor, and third one is 6, the third divisor. So every time what we are getting, so if we are dividing with these 7 and 9, we are getting the 5 and 3 as per the given
Yeah.
statements, and the same number is divided with our given divisor. So we are getting
Yeah.
0 as the remainder. Look at this. So how do we find the next number that satisfies both the statements? So from here we will have to think about that. That what is the next number? Any number other than 12 that exactly satisfies all these three conditions. That if you are dividing by 7, we are getting 5. If you are dividing by 9, we are getting 3. And if you are dividing by 6, we are getting 0. So let's see. Values satisfying first statements are in a arithmetic progression. First term is 5 and common difference is 7. So this was the sequence. We have seen that 5, 12, 19, 26. All the numbers are satisfying the first statement. Then values satisfying second statement are in second arithmetic progression, first 3 and common difference is 9. That was common difference 7 and here 9. The sequence is 3, 12, 21 and 30. So we have already written these two. Am I right?
Right.
So when we are taking all alone, the first statement, so we at that time we had this one, and next time we were taking this statement all alone. So we made this sequence. So you can look back to the slides. Anyhow, and we have selected the 12 that is satisfying. 12 is the common number which is satisfying this condition also. So from here, therefore, values common to both statements will be an AP. AP means arithmetic progression. Arithmetic
Okay.
progression. First term will be 12. Common difference will be the LCM of two common differences, 7 and 9, that is 63. The sequence will be 12, 75, and 138, and so on. So every time you are adding 63 to get the next one. So
Okay.
12 plus 63, 75, 75 plus 63, 138. So that's here we are using the mathematics of LCM. We are using the mathematics of the arithmetic progression. We are using how to find the common difference, that is D. So that is all about the 2 or 3 things are mixing together. Those are all the mathematical form. And I'm sure that you know what is the arithmetic progression, what is the geometric progression, what is the harmonic progression or the sequence and series. You might have gone through
Right.
those topics. And I am very much
Yeah.
sure that you have learned a lot of things about the LCM and GCF and
Yeah.
HCF. So that is all coming together over here. So in this problem, we can make the sequence starting the 12. 12 is the number which is satisfying both the conditions and this one also. So next, 75, that is out of that sequence. That 12, then 65, then adding 63 to more, this is set. So this is the next number in the sequence we were talking about in the previous slide. So leaves a remainder 5 and divided by 7. The first condition is satisfied. Look at this. And
Okay.
when we are dividing this by 9, so the second condition is satisfied according to the second statement. And when we are dividing, it will give 3 and divide by 6. So here, look at this, that this is slightly different thing. So at this time, that was 0, and here we have 3. So counterexample exists, statements together are not sufficient.
Right.
Okay, if you are using the both statements, once again, these statements are not satisfying because this condition is satisfied, this is also satisfied, but here we are not getting the 0, not the same, not the unique remainder from where we have started.
Right.
So these two statements are not sufficient. Eliminate choice C. C was saying that both together are sufficient. So eliminate C. Now we have two more. One is D and E. So that's why eliminate choice C. Answer choice is E. That both are both are not sufficient. Okay.
Okay.
One was all alone. Second was the second. Third one that combination of 3. Both. The fourth one was neither. So the last one, that was the neither A or that. That answer E is neither of them. So E is the last choice. And I will show all those choices because those choices are common everywhere. Anyhow, so our answer is choice E. So from here we have learned a very important method. This is a problem all about the data sufficiency. But if you're asked to find the common divisor, so what you will have to do, that you will have to get the LCM of those numbers. So if you can get the LCM, then you can find out the difference and you can make the sequence. So in this way, you will find those numbers which can be divisible by the given numbers. So if you are looking for the common divisor, so you will have to find out their LCM, the least common multiple. Then that least value will help you to find out the other multiples, the factors, and so many things. So this is the way to tackle the problem. Now, look back if you're just recalling, visualizing that problem, that we are not going to solve that question, but we are just looking for the condition that if somebody is asking you that I am putting this problem and these two helping information is given to you, this information and this information is also given to you, and you are asked to find the solution. So immediately you must say that these two statements are not sufficient.
Right.
The first is not sufficient all alone, the second is not sufficient all alone. The first is sufficient, but the second is not sufficient. The second is sufficient, but the first is not sufficient. The combination is not sufficient. Neither first nor the second, nor the combination. So nothing is sufficient for that. So at the beginning you must say, sorry, it cannot be solved with these two conditions, these two statements. So please tell one more that will sufficient that will make the answer possible. So that's that's why I am calling it our reasoning, quantitative reasoning. What I mean to say, so whatsoever the problem you are tackling over there, so this step you cannot eliminate to get the right answer if you are not using the hit and trial method. So you will have to recall all these things. So I'm sure that I am just putting a few questions for you for the long weekend, and when you are going to solve those questions, those problems, so you will make use of all these things. Am I right?
Okay. All right. Sounds good.
Okay. So this is the SAT practice test. So problem solving, easy way to solution. So definitely I will send you when I will get the time, so I will have to just make them in a proper form. But that is for your practice. What I mean to say, this is not the task. This is just for the practice that a few problems, not more any, they may be five or six or three. So definitely, I am not taking your time. It will not take larger lot of time. So it's just in a one sitting, you can solve all those and you can
Yeah.
discuss. I will also outline the solution. Outline mean that I will put some hints to each and every problem. So that will be the assignment. So today late night, I may get the time definitely, and I will send this type of the test to you just to sit all alone and make use of all these arguments and select the right answers and then rematch the answer which we will provide to you. Okay, it's all about
Yes.
that. So enjoy your weekend. I think there is a big change in America, and
Yeah.
definitely something will become, the things will become better and better. So as
Yep.
the this time will go on. So enjoy yourself, and it's time to say Allah Hafiz to you. So
I love this.
thank you very much.